This tutorial will focus on the contents of the Designer tab, which contains all of the necessary parameters to build a virtual lithium-ion battery. To get started, we'll create a new case by clicking on the shortcut icon up here in the corner. We'll enter our case name and then tell Autolion where to save it on the computer. For this case, we'll create an 18650 cylindrical cell, so the overall dimensions will be preset to that geometry. We can look at the basic dimensions of the battery here in the Package tab, which is the first of several drop-down menus which are used to define the information about the battery. These settings will be different depending on the type of geometry you choose, which is covered in more detail in another tutorial video. For now, we'll just use the default 18650 settings. The next major tab here is the Electrode Assembly tab. This contains all of the parameters for specifying the properties of each electrode, such as the foil thickness, active material type, electrode composition, and the electrode thickness. Different chemistries can be incorporated by using the drop-down menu in the Active Material node. This displays the various properties of each material, which can be modified by navigating to the material editor under Tools, Materials. Simply type the value you would like to change and click Save Update to make the changes. Elements in the electrode formula, such as the conductive agent or binder material, can be easily edited by clicking on the value and entering the desired input. For these settings, make sure that the total weight percent for each element in the formula equals 100%. The parameters found in the Coding tab are some of the most important details which dictate the performance of the battery. For example, if I increase the loading, which governs the mass of active material used in the electrode porosity will decrease, while the reversible capacity increases. Then, if I increase the electrode thickness, the porosity will increase, while the reversible capacity decreases. Creating a battery with thinner electrodes will typically yield a higher power cell with a lower capacity. Batteries with thicker electrodes will be the opposite. They'll have lower power, but have a higher total capacity. The same parameters apply for the negative electrode as well, with the only difference being that the N to P ratio of the cell determines the loading for the negative electrode. The Separator tab allows you to input the various parameters pertaining to the separator, such as thickness and porosity. In the Electrolyte tab, you can specify the concentration and density of the electrolyte in the cell. Finally, in the Cell Specifications tab, we are presented with a concise summary of the cell which we've designed, which includes the surface area, volume, weight, and capacity. With a little bit of practice, you'll be designing cells in no time. You can use these inputs to model pre-existing, commercially available cells, or you can design your own cell from scratch. The possibilities are really endless here. Be sure to check out our case studies to see how the batteries you design in Autolion can be used for real-world engineering applications. Thanks for watching.